morning. I'm Jon Norenburg. I'm chairman of the Department of Invertebrate Zoology, and I'm curator of Nemertea, and some of my colleagues would say of all of the odd phyla that we have. It's a pleasure and an honor for me to be able to be here today and share my seriously awesome worms with you, if I could put it that way. A few of you know that I work on Nemertea, which is one of the least known of the 30 animal phyla, and most of you justifiably have no idea what a Nemertean is. For some, the phylum's most important claim to fame will be that Lineus longissimus, shown here, is the Guinness record holder for longest animal at an estimated 60 meters long. Most Nemerteans, fortunately, are substantially shorter than that. Nemerteans occur in all marine habitats, and some are found in freshwater and terrestrial habitats as well. All are more or less predators. Some are colorful, like these. Most are not. While I have lots of Nemertean tails, my recent focus has been on two genera whose species are among the tiniest Nemerteans, some no more than 1 to 2 millimeters in length. These two genera are interesting because they afford opportunities to study questions of broader relevance. For instance, adaptation, miniaturization, biogeography, speciation. And I'm going to introduce you to only one of the two, the genus Carcinonemertes. Their attraction, in addition to being among the smallest and most difficult of Nemerteans, is that they can be of economic importance and probably as a tail, will be of more interest to you than some of my other worm tails. Many of you should care about Carcinonemertes. They are particularly fond of eating crabs that people like. The blue crab, Dungeness, king, snow crab, and even some lobsters. Except for taxonomic reports, the worms were largely ignored for about 100 years as sort of an odd novelty, until about 40 years ago when some Alaska fisheries biologists thought that there might be a relationship between these odd worms and localized crashes of crab fisheries. In fact, now there is a hypothesis that Carcinonemertes led to the collapse of the Central California Dungeness crab fishery in 1960, and that fishery has never recovered. So this is the animal. On the left, it's actually slightly squeezed under a cover slip. This is boring even by Nemertean standards. Like many, perhaps most of its 500 relatives in the suborder Monostolifera, it preferentially preys on crustaceans. In this case, crabs and some lobsters. And yes, the scale bar on the right side indicates that it's about 1/10 of a millimeter in diameter. But no, it's not a parasite. This worm has chutzpah and expensive tastes. Unlike its relatives, Carcinonemertes has evolved beyond the undignified need to chase or ambush its prey. It feeds at leisure on crab caviar, the developing larvae brooded by female crabs. Carcinonemertes are obligate symbionts. They live on crabs, and via biochemical cues from the crab, they match their life history to that of the host. So juvenile and adult worms live on various external surfaces of the host. On the left, you see the gills of a blue crab, and the little pink dots are the adult worms. And on the right is another crab where they live on the abdomen or in crevices on the body surface, here shown by lots of little pink dots. At the appropriate cue, the worms migrate to the egg clutch to feed, shown in the bottom two panels. After feeding for a few days, the adult worms become reproductively mature and deposit their own egg strings among the crab eggs. The smaller worm eggs hatch much more quickly. A worm larva may swim away to find a new host, or it may reinfect the same host. Evidence that the larvae are capable of absorbing amino acids that are leaked by the host led us to believe that this was their primary form of sustenance. So I was actually very surprised to discover on one of my field trips that the worm larvae themselves can start feeding on the eggs immediately. So what you see on the right panel is a big sort of basketball-sized crab egg with a little white blip on the bottom. That's a newly settled larva. And then the yellowish-orange fellow on the extreme right is a larva that settled about an hour before that and has already been feeding. Now, we knew that we probably had at least two species, one with and one without eyes, but further discrimination of species is exceedingly difficult. Most of the early encounters were attributed to the first species described, not by features. They weren't really distinguished by the features of the worms. From this starting point, we generate a lot of questions, some of relevance to Carcine and Emertes and some of more general relevance. So with molecular lure in our site now, we sampled about 110 species of crabs and lobsters, among which we discovered 62 new host species associations. At this point, we've looked at the genetic data for worms from 25 host species. We found plenty of cryptic diversity and evidence for lots of species. We were surprised, however, by the degree of overall genetic divergence, shown here in pink. Basically, it was for Carcine and Emertes, it was almost equal to that of all of the rest of the Monostellifera. I won't belabor our findings too much at this point, except to note that our data show modest evidence for coevolution of host and worm lineages, but with very notable exceptions that could be relevant for fisheries management. In particular, one worm species infests species of 5 crab families, and 3 crab species each are infested by more than one species of Carcine and Emertes. And I will end there. Thank you very much.
Well, you started your talk by suggesting there may be some effect on our economy by this knowledge. What were you talking about?
The question is that there might be an effect on the economy. In this case, for instance, if it's true that these worms led to the crash of the Dungeness crab fishery in Central California, that fishery no longer exists as an economic force in Central California. And in fact, in Alaska, where they have these localized crashes of crabs, basically the worms eat all of the eggs that are being carried by the mature female crabs.
Is there something we can or should be doing about that?
The question is there something we can or should do? It's basically a question for fisheries biologists, but one of the things that happens in management of crabs is they throw back the crabs carrying the eggs. That's where the worms hang out. They have no interest in male crabs. The worms need female crabs. And so in effect, we're actually increasing the concentration of worms. So that should be a factor that needs to be considered. The other question is whether these worms can be introduced with the various invasive crabs. We have lots of problems with invasive crabs these days. And the potential that you introduce a new worm that shouldn't be where it is and that may be a more efficient predator is a possibility. It's hard to say. And really, we need to do some serious fishery studies on these. I've really only been looking at the taxonomy.
Do you know if there's any discussion with the fishing industry about these things?
The question is there any discussion with the fishing industry? I keep trying to interest them, and until
Finding any interest?
Quite frankly, no. They're willing to give me worms, but they have not been willing to put, for instance, students to work on the project. I've offered to supervise students in Alaska, and they're all very interested in knowing about these worms, but until there's another crash, they're not terribly interested in funding the work.